Okay, good afternoon guys for the second time. So we are going to look at unit 3. There's one unit left after this. This talks about logical data modeling or the development thereof. So in essence what we are talking about is actually developing a small database of sorts for our system. But now, which classes capture the data? Which type of classes? We discovered 3 types of classes: boundary, control, and entity. Which of them covers the data? Okay, this is going to focus on the entity classes, and we will be working on that. You will see the objectives of data modeling is to quickly understand the purpose of data modeling, the different stages of data modeling, and then we're going to also look at the difference between the relational databases and object orientation. Then we look at the transformation guidelines and how do we go from classes to a data model. Okay. Then we're going to look at store procedures, use-defined functions and triggers, identifying operations which should be implemented as either store procedures and triggers. So what you will see, this portion is part of database design. It's now a matter of designing the actual database according to our use case utilization, some project guidelines and supplementary specifications. So we are going there. So the purpose is to ensure that the persistent data is stored consistently and efficiently, to define the behavior that must be implemented in the database, and the focus lies on the transformation of our persistent classes to a data model. So we're more going to look at this transformation also. So what you will note is that these 2 different approaches mainly to design a data model. One, the traditional approach is to go and create a logical data model, a physical data model, and then to go and implement all of that. Okay. That can either be from a bottom-up approach or a top-down approach where you're designing it. But what we are following is more method that we're going from our analysis classes to design classes later on, and to go to a logical data model to physical data model. Okay, so there is a bit of transitioning from there. Okay, so what you will note is that this is quickly introducing the stages of data modeling, where we're introducing conceptual data modeling. Now, conceptual data modeling is a method that we are developing our data model as a concept still. It might be a rough sketch on paper. Okay, this is also part of the traditional approach which was followed. Now what you'll see, this gives us a graphical data model that shows a detailed specification of the overall structure of the data for a project or organization. It's still just a concept. It is independent of any implementation technology. Okay? And database management system decisions. So ultimately, we have not really at this point made a decision about what database am I going to run it on. What types of databases do we have? You can store data as either flat files, some text document, a CSV or text document. You can store it in Excel. You can store it in Access as a small database. Okay. Then you can have hierarchical models, which banks was quite using, and then also as relational data models. Okay. So these different technologies which is available. But what type of database management systems, DBMSs, do we have? Microsoft's SQL Server, MySQL, Oracle SQL, DB2, Most of those are relational databases. Then you now start to get to graphical databases and object-oriented databases. That's now where MongoDB comes in. Things like that. Okay. Now you'll see the logical data model is a refinement of the conceptual high-level one which we have to create a detailed logical data model. Okay. Then the logical data model forms part of the data model and is sometimes even optional. It is derived from the conceptual model by transforming into a logical data model, and in this case it's now becoming dependent on the technology. So meaning that we need to make a decision based on what type of technology do I want to use. Am I going to store it in a flat file, or am I actually going to have an Access database or a DB2 database or a relational database? Okay. But it's still independent on the actual vendor. We have not decided what vendor are we going to use. Then there's also physical data modeling. It's the final stage of the development in the design of the database. In this stage, they're consisting of creating detailed database table designs, relationships for it. Now, this is also derived from the logical data model and is dependent on the target implementation. So in this case, it is dependent on the technology and the database management system. So does all DBMSs work the same? To some extent, yes. But do they have the same data types available? Not always. Do they have the same way of implementing tables and data structure and so on? Not always. Okay, so when we get into this, we need to make a decision on the DBMS. Then we're also looking at the tables in the physical data model to see have they been defined correctly in terms of do they have the correct columns, keys, and the indexes as needed. Then we also might look at triggers and store procedures. We'll speak a bit about those later on. Okay, then we quickly get into the comparison between relational databases and object orientation. Now what you'll note is a relational database is more focused on the storage of data. It's suited for your ad hoc relationships and reporting applications, where you would just like to pull data from the database and have it displayed. Okay. So ultimately it exposes our data and the column values for us, and the object-oriented systems focuses more on the actual behavior, on what are we going to do. Okay. Creating something, manipulating the data. It's suited to handle state-specific behavior where data is secondary. So you would like to register for a subject, so you register. Ultimately, yes, data is going to be stored, but it's a secondary act from that. So it hides the data. So there is not a total, we can't go directly from a relational one to an object-oriented one, we'll see now also. This is one of the forms of depicting the relational data model. What we see here is we have an order, we have a line item, and we have products. And in this case, we have entities and relationships, what we can see. But then we also can have it depicted as an object model, where we're starting to see our classes. I have an order, line item, product. So I still have my class, the attributes, the data types of the attributes, the relationships is all depicted on it. Okay. Now a lot of times we might even use a persistent framework or persistence framework to translate between my application, my classes, and my objects to the possible database which I might be using. Okay. Now this framework is the guy sitting there in the middle. he translates, and he's the guy doing this translation for us. So what makes it nice is that there's a lot less time spent on the development of the actual translation. It also reduces the maintenance. It makes it a bit easier for us. Okay, now we will quickly look also at the transformation, as we mentioned, to transform the class diagram to a logical data model. Now, in my design one, I might have a class. That class is going to become a table in my database. So if I have an attribute, what is the purpose of an attribute? To store some data. That in my data model will become a column. If I have an association, a relationship, then will have a non-identifying relationship. Association class, intersection. So you will note that there is a translation from one to the other. Okay. Then they're mentioning to us that if we want to map our persistent classes to some table, what does this allow us to do? Every row will be regarded as a object. Okay. Now, where a column in my table is really equivalent to an attribute of my class, and a class may have some transient attributes that are not going to be persistent. What does transient mean? Transient means that it's temporary. Okay. So we might get to a place that one of our attributes is only temporarily used. We don't need to store it in the database. It might be from some calculation or so. Okay, then they quickly showing to us that if we are mapping our persistent classes to a table, I might have my attributes in my class. They will become normal columns for my class on that side. Okay. So then there is quickly a matter of persistent attributes and keys. What do we use? So we might need to ask ourselves some questions on identifying the information that is going to be used to represent our data correctly, to quickly find the values. Okay, so can the attribute serve as a key or part of a key? What is a key? A key is a field which is used to uniquely identify something. What would uniquely identify you? What would uniquely identify you? Your ID number. In the university context, what uniquely identify you? Your student number. Okay, so it's an attribute that can serve as a key or part of a key. Then they're saying to us there as if we're looking at it, there's a custom ID that can be used to represent it. Then is the attribute unique? So one combination which would not be very good would be your name. Okay, because your name is not unique in global context of it. Okay. Then are there a minimum and maximum value for the attribute? Can it grow up into bigger portions? Okay, what is the minimum value? Will it be possible to search using that attribute as a key? Okay. Then are numeric conversions required? Do I need to migrate it from one data type to another? If we need to do that, it's not always a very good key. Okay. then who can create, read, update, or delete the attribute? Okay. That might be included in some views at some point, and of volume and frequency information available. Why does the volume and frequency play a role? Talks about a matter of how often are you going to store data in that table or in that database? How often do you think you're going to retrieve data? Okay. So then there's also an example where they have an association between a course and a subject. And what are we seeing from there? They've introduced from the subject to the course, we are seeing that inside the course, they've identified and added a course ID. And if we look at the subject, there's also now a corresponding field in there, which is called a foreign key. Now, a foreign key helps us to relate one table to another table based on some key combination. Okay. So then there's also continuation where we're looking at aggregation, and from this, what can I see? I can see that there's a student and there's schedule, but inside the schedule they've also added the student ID. Okay. So there's a foreign key added into the schedule for the student to uniquely identify it. Okay. Then there's also a continuation where they've the student information, where they're just modeling it with a filled-in diamond. What does that filled-in diamond mean? Who can remember? Composition. Okay. So what we're seeing here is a student and schedule and a composition relationship. And then in that discussion, they're telling us that that can be implemented the same as aggregation, but you would now probably have on the foreign key a delete constraint, which you will place on the referential integrity of it. Okay. Now, then they quickly mention inheritance. It really supports two ways of handling it, either as separate tables and creating the structure, or if you normalize it and take all the children which you would have had and create one big fat entity from there. Okay. Then there's also mention of many-to-many relationships and what can be applied to this, where we're adding an intersection table to capture this information. Okay. Then there's quickly a mention also to reiterate this transformation. If we have a many-to-many relationship, what does it mean to us? They tell us that we are going to have an intersection table that sits there. Okay. So that it captures the information which describes the relationship more. Because this information then do not really belong with either one of the entities that belongs to the relationship. Okay. Then there's some decisions which we might need to make to say, but how am I going to handle the behavior which is related to my data? how am I going to handle the retrieval of data, the validation of data? Okay. So that is a place where we start to look at the store procedures, use-defined functions, and triggers. Now, you will see a store procedure are allowing us to do similar things like a small program. It can go and create something for you. It can delete something, remove it. Now, use-defined functions are code that can be used to return either a single value or a table of values from that portion of code. Okay. And a trigger is special code batches that could respond to specific events. Okay. Now, then they're continuing into the discussion just to mention in more detail where store procedures is an ordered series of SQL bundled statements. And it accepts input and output parameters and can be used to perform virtually any function within a database. It can be securely accessed within the central location and is created and stored on the actual database. Then there's also mention of functions. Now, and triggers, but what we would like to get to this portion. We need to determine if any of our initial operations, our behavior, which I have in my class diagram, my sequence diagram, do I need to do it using either a store procedure, a function, or a trigger? Now, if we have an operation that deals with CRUD operations, create, read, update, and deletion of data, of my persistent data, then I might model that and might develop it as a store procedure or a function or a use-defined function. Okay. If there's an operation in which a query is involved in some computation, if there's going to be some calculation based on data which is already stored, then you might model it as a function. Okay. If there's operations that need to access the data for some data validation or some validation of your actual information, okay, then that might be modeled as a store procedure, for example, or even a function. So there's quickly example, if we have had the class student and there was get tuition, add schedule, get schedule, delete schedule as prerequisite. Some of those operations can be modeled as functions and some as store procedures. For example, get tuition is really just a matter of retrieving data, getting information. Adding schedule is a CRUD operation because we are going to create an entry there. Get schedule is again retrieval of information. Delete schedule, we are now removing it. Good place for a store procedure. Okay, so these are good candidates. And then there's a mention quickly, just what do we need to look at? There's a few checkpoints for database design. And then there's a few review database design steps and questions to all of this that can be useful. Guys, what you will note as part of the material on Blackboard on this, there is already an exercise, there is already an introduction on how do we model using IBM software, how do I model a data project, and then developing a logical data model. How do we do it in Data Architect? Okay. Any questions?